Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2017, Paper 1, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. So we're looking at paper 1 from the June 2017 series of papers. You'll notice this is actually dated on the 25th of May rather than June though, so it's a little bit earlier. But it's foundation tier and we're looking at paper 1. Okay, question 1. How many minutes are there in 3.5 hours? Well, you should know that 1 hour is 60 minutes. So 3 hours is going to be 3 lots of 60, which is 60, 120, 180 minutes. And then half an hour is 30 minutes, so adding that together, that gives me 210 minutes, isn't it? So it's that one there. Question 2, work out a quarter plus 0.5. Okay, so these are in, well, they're mixed, aren't they? I've got a fraction and a decimal. I think the easiest thing here is to convert the fraction into a decimal number. Now you should know that 1/4 is the same thing as 0.25. It's just a good idea to remember these common fractions, what their decimal equivalent are going to be. So 0.25 plus 0.5. Okay, now when you're adding numbers that are decimalized, just make sure that you line them up properly. So you line up the decimal points above each other when you add in. So that's going to give you 0.75, isn't it? It's that one there. Question 3. Which of these shapes has the most sides? A hexagon, an octagon, a rhombus, or a trapezium? Okay, so a hexagon has got, you should know, has got 6 sides. Anything beginning with hex means 6. Anything beginning with oct means 8. Octopus, octagon, 8 sides. Now a rhombus is a type of quadrilateral, isn't it? So it's a diamond-shaped quadrilateral, so that is got 4 sides. And similarly, a trapezium is a quadrilateral. That's also got 4. So the shape with the most sides is the octagon with 8. Question 4. Solve x minus 3 is equal to 0. Circle your answer. So if x minus 3 is equal to 0, we can take this negative 3 and we can change sides, and move it over the equal sign like that. So that would give us x equals 3, which is that one there. Okay, another way of thinking about it, if I've got x minus 3 is equal to 0, you could also think about it as adding 3 to both sides. And again, that will give you the same results, x equals 3. So 2 different approaches there. Either use inverse operations, change sides, change signs, or you can use the balance method where you're adding or subtracting the same amounts to both sides. Okay, either way, the answer is x equals 3. Question 5. Work out 58 times 73. Now, you need to have an efficient and accurate way for multiplying out numbers. some students know the column method, which is great if you can understand it. 8 3s, 8, 16, 24, carry the 2, 5 3s are 15, and the 2 makes 17, add a 0, 8 7s are 56, 6 here, carry 5, 5 7s are 35, and the 5 make 40, and then add up 4, 13, 2, 4. Okay, so I made that 4,234 using the column method. Now, this is quite a difficult algorithm to learn. Some students do struggle with it. Primary schools tend to teach the grid method, so they would have something that looks a bit like this. So you put 50, 8, 70, and 3 and do it that way. I actually think this method is pretty inefficient. I don't really like it very much. What I think is quite a nice halfway house between the two of them, if you haven't got a decent way of multiplying yet, is the Napier's bones method. Some people call it the Chinese method incorrectly, but it involves drawing a grid. Okay, so the hardest thing about Napier's bone is drawing the grid in the first place. Once you've got the grid drawn, you can just write your numbers around the side. So my first 2-digit number I write this side, and my second 2-digit number I write around here. So 58 times 73. Then in each box we write what we get when we multiply those two things together. So 5 7s are 35. So I'm going to write that in there and there. 8 7s are 56. I'm going to write it here and here. 5 3s are 15. And 8 3s are 24. Okay, so once we've got them, or the grids filled out, we add up along the diagonals. So in this first diagonal, it adds up to 4. This next diagonal has got the 6, 2, and 5, and it adds up to 13. I'm going to put 1 in there and carry 1. My next diagonal has got 5, 10, 11, 12 in it, so I put the 2 here, carry 1. And then my final diagonal's got 4 in it. So again, you can now read the answer off 4, 2, 3, 4, which matches my answer from the long multiplication. Now, like I say, I find this method kind of the Goldilocks method between the two approaches. It is more efficient than the grid method, but it is easier to understand than the column method. So I tend to teach my students this way. So I think I might do a video on the Napier's bones method, because I think it's a nice way of multiplying. So if you're interested and I've made it, there might be a link appearing at the top at some point. Question 6. 500 people are asked if they drink coffee. 9 out of 10 say yes, and 20% of the people who say yes drink at least 3 cups each day. And we're asked to complete this frequency table down here. So we've already got the 500 people in here that drink coffee. So we need to decide how many said yes and how many said no, so we can fill those two circles in first. So we've got 500 people and 9 out of 10 said yes. So we want to find 500 times 9 out of 10 to find out exactly how many did say yes. So dividing through by 10 would leave me with 50. And 50 times 9, 5 9s are 45, so 9 50s is going to be 450. So I got 450 then who said yes, so then the remainder up to 500 would have said no, so that's another 50, isn't it? So 450 would have said yes, and 50 would have said no. So let's put 450 here, and then 50 here. Okay, so now we've got to decide what the second question was, at least 3 cups a day. So what does it say? 20% of people who say yes drink at least 3 cups each day. So we need to find 20% of 450. So 20% of people say they say yes, they drink at least 3 cups a day. So if 100% of my value is 450, then what's 20%? Well, 10% is easy to find. I just need to divide it by 10, which is 45. So then if I take 2 of those, so I times that by 2, I can find 20%. So if I also do the same over here, times 2, I shall find that 20% is equal to 90 people. So 90 people say yes, they drink at least 3 cups a day. So 90 up here. Then so the remainder say no then. So 450 less 90. Well, 450, if I take off 100, I'll get to 350, which is 10 more than 90. So let's come back up another 10. So it should be 360, say no then. Okay, so I think we're done. Question 6b, what fraction of the 500 people drink at least 3 cups of coffee each day? Give your answer in its simplest form. So we worked out that there were 90 people who drink coffee 3 times a day. So that is 90 out of 500. Okay, so I can see straight away I can divide that by 10. So that gives me 9 out of 50. Now 9 has only got, well, it's got 3 divisors, isn't it? It's got 1, 3 and 9. 3 doesn't go into 50 and 9 doesn't go into 50, so that is as simple as it's going to get. So it's 9 out of 50. Question 7. By rounding each number to the nearest 10, estimate the answer to 61 times 47 divided by 102. Okay, so let's round off each number first. So 61 to the nearest 10, is it nearer 60 or is it nearer 70? Well, it's clearly nearer 60. 47, is that nearer 40 or is it nearer 50? 5 or above rounds up, 4 or below rounds down, so that's going to be rounded up. 102, is that closer to 100 or 110? So 2 rounds down, so that is 100. Okay, so I got 60 times 50 divided by 100. Okay. Now I'm going to divide one of those, I can cancel one of those 10s into there, and 1 into there, and it leaves me with 6 times 5 divided by 1, which is just 6 times 5, isn't it? 6 times 5 is 30. So my estimate is going to be 30. Question 8. Nadia has £5 to buy pencils and rulers, and we can see that pencils cost 8p each and rulers cost 30p each. She says, I will buy 15 pencils, then I will buy as many rulers as possible. With my change, I will buy more pencils. Okay, so how many pencils and how many rulers does she buy? Okay, so let's go through this one step at a time. First off, she says she's going to buy 15 pencils. So we need to work out what 15 times 8 is. I think I'm going to work in pence all the way through here. So I'm going to convert that £5 into 500p. I think that's probably the easiest thing. Okay, so and then I can do all my other things in pence. So I buy 15 pencils at 8p each, so I need to work out what 15 times 8 is. Well, I know that 10 eighths are 80 and 5 eighths are 40, so 15 eighths is going to be 80 and 40, which is 120. So she's going to spend £1.20 or 120 pence on pencils. Okay. Right. So now, what's the change? How much is she going to have left? Okay. So that leaves how much? So she had 500 pence or £5, and she's now spent £1.20 or 120 pence. So that's going to leave her with 500 take away 100 is 400, 400 take away 20 is 380 pence. So she's got 380 pence left. So, and with her change, no, I'll buy as many rulers as possible now. So out of my 380 pence left, I want to buy as many rulers as possible. So in other words, I want to see how many 30s fit into 380. So buying rulers, I've got 380 divided by 30. How many times does 380 divide into 30? That's the same thing as 3's into 38. How many times does 3 fit into 38? Well, I know that 3 goes into 30 10 times. So then you've got 33, 36, 39. So it's going to go in 12 times, isn't it? So it's going to go in 12 times remainder. So what's going to be left over? So 3 divided by, well, so 38 divided by 3 would have 2 left over. So 380 divided by 30 is going to have 20 left over. So the remainder is going to be 20. She's going to have 20p left. Okay, so with my change, I'm going to buy more pencils. So she's bought 12 rulers and 15 pencils so far, but she's got 20p left. So she's going to buy more pencils. So how many more pencils can she buy now then? So how many more pencils? So she's got 20p left, and we know that rulers cost 8p. So how many 8s fit into 20? That is 2 times remainder 4, isn't it? Because 2 8s are 16. So she's going to have 2 remainder 4. Okay, so what's that in total then? So she's bought how many pencils and how many rulers does she buy? She bought 15 pencils there plus another 2. So total pencils is 15 plus 2. So she bought 17 pencils, and rulers she bought, well, we said that she bought 12, didn't she? So she bought 12 of those. So 17 pencils and 12 rulers. 17 pencils, 12 rulers. Question 9. Work out 25.68 divided by 12. Okay, I can probably get away with doing short division here, because normally I only do short division with 1-digit divisors, but 12 isn't that far off a 1-digit divisor. So we might be able to squeeze in our remainders without too much issue here. Okay, so short division says, how many times does 12 go into 2? It doesn't. So how many times does 12 go into 25? It goes in twice. 12, 24. So 12, 24 goes in twice, doesn't it? Next one up is 36, which is too many. So it's going to go in 2 times. And then the remainder is, well, 2 12s are 24. So the remainder is 1. So I'm going to carry 1 over into the next number. So now I see how many times 12 goes into 16. It goes in once, and the remainder is, well, 112 is 12, so that's a remainder of 4. And then finally, how many 12s go into 48? So I've got 12, 24, 36. The next one up is 48. Goes in 1, 2, 3, 4 times. So it goes in 4 times with no remainder. Now, because the decimal point is here in my original number, my decimal point is going to be here in my answer, just right above it. Okay, so wherever it is in the sum, that's where it goes in short division. So the answer is 2.14. Question 10. Work out 3/8 of 11. Now, normally when you've got fractions times a whole number like that, you would divide through by the denominator. So try and divide your number through by 8 and then times by 3. But 8 doesn't go into 11, so that's not going to be very helpful here. I think probably the easiest way is to rewrite 11 as a fraction. So if I rewrite 11 as 11 over 1, it's 11 once. Then we can try and do top times top and bottom times bottom. So what am I going to get there? 3 times 11, 33. 8 times 1 is 8. So this is 33 over 8. So I need to write this as a mixed number. It's not a mixed number at the moment. It's a top-heavy fraction or an improper fraction. So we need to see how many times 8 actually goes into 33. So know my times table for 8. 8, 16, 24, 32. It goes in 4 times, remainder 1. So because it goes in 4 times, the whole number part of my mixed number is going to be 4. Because the remainder was 1, the numerator part of my mixed number is going to be 1. And because my divisor was an 8, it's going to have an 8 as my denominator there. So my answer is 4 and 1/8. Question 11. A triangle has perimeter 32 centimeters, a square has perimeter 40 centimeters, and the two sides of the shapes are put together to make a pentagon. Okay, the question is on the other page, and it says work out the perimeter of the pentagon for 4 marks. Okay, so the perimeter of a shape is the distance all the way around the edge. Now let's start off with the square because we know most about that. We know because it's a square, it's got 4 sides that are equal in length. Okay, and if I know that the total perimeter of this shape is 40, then I know that each of the sides is going to be 40 divided by 4, which is 10 centimeters each. So that's going to be 10, 10, 10, and 10. Okay. Now coming back, looking at our diagram down the bottom, this pentagon is made by sticking the triangle on top of the square. And you can see that that shared edge along there is the same length for both shapes. So this length here, this 10, has got to be the same as this side here of the triangle. So that has also got to be 10. Okay, now we're told that the total perimeter, well, the perimeter of this triangle is 32. So if that base of the triangle is 10, then that tells me that the other two sides of the triangle must be 32 subtract 10. They must add up to 22 between them. So it might be that this one is 12 and this one is 10, or this one is 11 and this one is 11. We don't really know. It doesn't matter. We're just going to use the fact that it's the total of the two sides is 22. Okay, so coming back to my diagram down here then, let's get rid of that bit there. We know that this side is one of the sides of my square, and so is this one, and so is this one. So they must be 10 each, 10, 10, and 10. And we know that these two sides are the top two sides of my triangle, and we know that between them they add up to 22. So then the total perimeter, or the total distance around this shape, is going to be my 3 10s plus my 22. So that's my perimeter, isn't it? So 3 10s are 30 plus 22 is 52 centimeters. Okay, so the answer is 52. Now notice they've given you space to work here. You don't have to use that space. If it's better or easier for you to work near the diagram, then do that. It still gets marked. The only thing that doesn't get marked is if you go over this edge, and that right in here is not a good idea because the papers are scanned in, so you have to make sure you keep your writing inside the box. But other than that, you can write where you like. So if it's easier to write next to the diagram, do your work next to the diagram. It's no problem at all. Question 12. A football team has P points where P is equal to 3W plus D. W stands for the number of wins and D stands for the number of draws. Now, any of you who follow the football leagues will be familiar with this formula. Every time two teams play, if they win, they get 3 points, and if they draw, they get a point, and if they lose, they don't get anything. Okay, so that is the formula they use in the Premiership and other tournaments for football. So a team has 6 wins and 2 draws. How many points does the team have? Okay, so we know the formula P, or points, is 3 times the number of wins plus the number of draws. So if W is 6 wins, I'm going to write 6 here then. So that's going to be 3 lots of 6 plus 2 draws. 2 draws, my number of draws fit here. So I'm going to write 2. So I've got 3 times the number of wins plus 2. 3 6s are 18 plus 2. That gives me an answer of 20. So the team has 20 points. After 33 games, a different team has 53 points. 11 games were drawn. How many games has the team lost? Okay, so after 33 games, a different team has 53 points. So we know that P is equal to 3W plus D. Now we know P here, we're told it's 53, and we know D here, the number of draws, we know that's 11. What we don't know is the number of wins or the number of losses yet, so that's what we need to work out. So what I want to do first is going to rearrange this formula so W is the subject and not P. So I can do that by taking this D over to the other side. So I'm going to get P subtract D is equal to 3W. And then I'm going to cross multiply this 3 to the other side, or divide both sides by 3. I'm going to get W is equal to P subtract D over 3. So that's my new formula for working out the number of wins. Okay. You might want to turn it around the other way if you want. So W equals P minus D over 3. Okay, now subbing in the things that I know then. So I know that P is 53, and I know that D is 11. So what is 53 subtract 11 all divided by 3? Well, 53 subtract 11 is 42. 3 goes into 42 14 times. Okay, so that's the number of wins. So the number of wins is 14. So we've got wins is 14, and we know that draws is 11. So what's the number of losses then? So if they played 33 games altogether, then the number of losses is going to be the number of games altogether subtract the wins, which was 14, plus the loss of the draws, which is 11. So 14 wins and 11 draws is 25 games in total. So take 25 away from 33, and that's going to leave me with 8. So there are 8 losses. Question 13. 2 plus 0 plus 1 plus 7 equals 10. Yes, it does. Make the following calculations correct. Use only the symbols plus, minus, times, divide, and the brackets. So I've got 2, 0, 1, and 7, and I'm aiming for the number -4. Okay, so if I add 2 plus 0, I've got 2. If I add on another 1, I've got 3. And if I then take away 7, 3 subtract 7 is going to give me -4. Okay, so that one's done. Right, 0. And I've got 2, 0, 1, and 7. Now to get 0 here, I can use the fact that anything multiplied by 0 is 0. So if I just multiply all these things together, okay, I'm going to get 0. 2 times 0 is 0, times 1 is 0, times 7 is 0. Okay, so that one works. Finally, I've got 2, 0, 1, and 7, and I need to make that equal to 2 to the power of 4. What is 2 to the power of 4? 2 to the power of 4 is 2 times 2 times 2 times 2, which is 2, 4, 8, 16. So actually, that's equal to 16. Now, is there a way of getting this number equal to 16? Well, if I add those two together, I'm going to get 8. And if I add those two together, I'm going to get 2. And then if I times them together, I should get 16. We just need to take care of order of operations because multiplying normally comes first. So if I want to add those two together first, I'm going to put brackets around them like that. So 1 plus 7 is 8, and I need to times it by, and again I need to put brackets around these as well. 2 plus 0 is 2, and 2 times 8 is 16. Okay, done. Question 14. A number is picked at random from the first 4 prime numbers, and then a number is picked at random from the first 4 square numbers. The two numbers are added to get a score. Complete the table. Okay, so we've got a possibility space here. So first off, the possible numbers at the top are not all completed. So the first 4 square numbers are 1, 4, 9. So that's 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. So there should be a 16 there on the end of that row. Similarly, we've got to work out the missing prime number here. The first prime number is 2, then 3, and then the next prime number is 5, isn't it? And then 7. Okay, so in the possibility space, we can add, and if it's add here, we can just add the two scores together and write it in the middle. There's one already shown for you here. Look, that you've got 3 here and 9 here, and you can see that's added together to give you 12. So we're going to do the same thing in all the other squares. We're going to add the number at the front of the row with the number at the top of the column together to give you the total. So here, this is 2 plus 1, which is 3. Next one is 2 plus 4, which is 6. 2 plus 9 is 11, and 2 plus 16 is 18. 3 plus 1 is 4, 3 plus 4 is 7, 3 plus 9 is already done for us, and 3 plus 16 is 19. 5 plus 1 is 6, 5 plus 4 is 9, 5 plus 9 is 14, and 5 plus 16 is 21. 7 plus 1 is 8, 7 plus 4 is 11, 7 plus 9 is 16, and 7 plus 16 is 23. Okay, so we filled out our possibility space. What is the probability that the score is a prime number? Okay, so there are a total of 16 different outcomes when we do this. So it's each one of the squares in my grid in the possibility space. So because we've got 16 squares, then my probability, which is successful outcomes, if you've forgotten what probability is defined to be, successful outcomes divided by total outcomes. Okay, so we know there are 16 possible outcomes because there are 16 squares in my possibility space. So we want to work out how many of those are prime numbers. Okay, so the primes are, well, we've written out some of them already. They're 2, 3, 5, 7. Let's write out a few more because our table goes up to 23. Next prime number is not 9, it's 11. Then 13, not 15 because it's divisible by 3 and 5. 17, 19, not 21 because that's got 3 and 7 in it. 23 is prime. Okay, so there are all my primes up to 23. So let's highlight anyone in the grid. I'm going to take that highlighting off because I want to use it now for highlighting prime numbers. So 3 is a prime, 6 isn't, 11 is a prime, 18 isn't, 7 is a prime, 19 is a prime, 6 and 9 aren't, 14's not, 21's not, 8's not, 11 is a prime, and 23 is a prime. So in my table of results, I've got 1, 2, 3, 4, 5, 6 now I've highlighted green, which means there are 6 primes. So successful outcomes would be 6, total outcomes would be 16. Probably questions, you never get any extra credit for cancelling down. I'm just going to leave it as 6/16. Question 15. In a school show, the ratio of girls to boys is 1:1, which means there is just as many girls as there are boys. Girls who sing to girls who do not sing is 1:2. So twice as many girls don't sing as do. There are 8 girls singing in the show. How many students are in the show altogether? Okay. So if the ratio of girls who sing to the girls who do not sing is in the ratio of 1:2, and we know that the girls who sing is 8, then this one here is times in through by 8. So doing the same to the other side, times in by 2, there must be 2 times 8 is 16. There must be 16 girls who don't sing. So how many girls is that altogether? 8 plus 16, it gives me 24 girls. Okay. Now the ratio of girls to boys was 1:1, so that must be that there's also 24 boys. So then the total in the show is going to be the number of girls plus the number of boys, which is going to be 48. So there are 48 students in this show. Question 16. P and Q are coordinates. Question 16. P and Q are points on the line 3x plus 2y is equal to 6. Complete the coordinates of P and Q. So let's start off with P first. For P, we can see that the x coordinate is 0. So x is 0. So if we've got 3x plus 2y is equal to 6, and we know that x is 0, then we've got 3 lots of 0 plus 2y is equal to 6. So 3 zeros are 0, which means 2y is 6, which means y must be, dividing both sides by 2, we're going to get y is equal to 3, aren't we? Y is 3. So this one here is 3. So then for Q, we know that the y coordinate is 0. So y is 0, which means I've got 3x plus 2 lots of 0, which is equal to 6. So now this time it's this term that disappears away, and I've got 3x is 6, dividing both sides by 3, I can see that x must be equal to 2, so that's got to be the point 2, 0. Okay, so I've got the points 0, 3 and 2, 0, which are points on my line, and we need to draw the line. It's the same equation, isn't it? 3x plus 2y is equal to 6, the same equation as part A, and we want to draw it from -3 to 3. So we can see that P is 0, 3 and Q is 2, 0, so we can plot those points straight on the graph. P is 0, 3, which is that point there, that's P, and Q is 2, 0, which is here. Now we could probably just draw the graph from those 2 points, but I always like to have a third point just to check. So let's just try a little bit further on the line. What's the value of y when x is -2? So I know that 3x plus 2y is 6. So if x is -2, 3 lots of -2 plus 2y is equal to 6, which is -6 plus 2y is 6. Adding 6 to both sides gives me 2y is 12, and dividing both sides by 2 gives me y is equal to 6. So at -2, y is equal to 6. That just gives me another point to plot, just to make sure I can line up my ruler nicely. Now I'm happy I've got enough information to draw the line. So taking a ruler, lining up neatly through those 3 points, and then drawing your line. Okay, don't start and stop at your first and last point. Your line should stretch the full length of the axes, like that. Okay, so there's my graph. Question 17. Circle the expression which does not simplify to y cubed. Okay, let's have a look at the first one. Y times y times y. Well, that is just a definition of y cubed, isn't it? So that does. Y to the power 4 divided by y. When you divide numbers with the same base, you subtract the indices. Y has got an index of 1, so 4 subtract 1 is 3. That is y cubed. Y squared times y, again, multiplying numbers together with the same base. You add the indices, that is y cubed. And then finally, y to the 6 divided by y squared. Dividing numbers with the same base. You subtract the indices. 6 subtract 2 is 4. That one is y to the power 4. So which one doesn't simplify to y cubed? That one doesn't. Write the number 6,005,200 in standard form. Okay, let's try and write it out as a number first off. So 6 million is 6 followed by 6 zeros. Well, 6,005,000, so that's going to be 005, 200, like that. 6,005,200. Okay, now we've got it written as a number. Now we can try and write it in standard form. So we're just going to write all the digits. 6.0052. I can forget about the last 2. So I'm not going to change it either way. So times what? 10 to the power of, well, if the decimal point starts here and we're going to end up 1, 2, 3, 4, 5, 6, we're going to move it 6 jumps to get it to there, aren't we? So that's times 10 to the power of 6. So my answer is 6.0052 times 10 to the 6. Question 19a. Use 8 kilometers per hour is equal to 5 miles an hour to convert 96 kilometers per hour to miles per hour. Okay, so 96 kilometers per hour. If 8 kilometers equals 5 miles per hour, then to convert this into miles per hour, I need to divide through by 8 and times by 5. So 96 divided by 8. 8's into the 80 go 10 times. 8 into 16 goes twice. So 8's into 96 are going to go 12 times. So that's going to be 12 times. So 96 divided by 8 is 12, and 12 times 5 is 60. So it's 60 miles per hour. X kilometers per hour equals y miles per hour. Use 8 kilometers per hour equals 5 miles per hour to write a formula for y in terms of x. Okay, now here y is clearly proportional to x, which means y must be equal to some multiplier of x, y equals kx. Now all we really need to do is find out what k is. And we can find k if we can find two values of y and x that go together. Now we've been given them here. So 8 kilometers per hour equals 5 miles per hour. So that 8 must be equivalent to the x, and the 5 must be equivalent to the y. So when x equals 8, y equals 5, means that 5 must be equal to k times 8. Subbing those two values in, rearranging, that gives me a value of k equal to 5/8. So my complete formula for y and x should be y is equal to 5/8 of x. Here is a circle touching a square. The area of the square is 64 centimeters squared. Work out the area of the circle, given your answer in terms of pi. Okay, so if I know that the area of that square, so area of the square is equal to 64, then each length must be the root of that then, because area of a square is length squared, isn't it? So L is going to have to be 8, okay, which means it is 8 from there to there. Now the formula for a circle is pi r squared. Now 8 is going to be the diameter of my circle, so the radius is going to be half of that. It's going to be a radius of 4, so my area of my circle is going to be pi times 4 squared. In other words, it's going to be 16 pi. So 16 pi. Billy wants to buy these tickets for a show. 4 adult tickets costing £15 each, and 2 child tickets costing £10 each. A 10% booking fee is added to the ticket price. 3% is then added for paying by credit card. Work out the total charge for these tickets when paying by credit card. Okay, so first off, how much is the total amount to be paid? So cost of tickets. It's going to be my 4 adult tickets at £15 each, plus my 2 child tickets at £10 each. 4 15s are 60, 2 10s are 20. Adding those together gives me 80. So the cost of the tickets is £80. Plus we need to put on the booking fee. Booking fee is going to be It's going to be 10% of that, so that's going to be £8, isn't it? Give me a total of 88. And then finally, I need to add 3% for paying by a credit card. Okay, so I've got £88. What's 3% of £88? So this is my credit card fee. So if I have £88, then 10% is £8.80, and 1% would be 88p. So 3% is going to be 3 lots of 88 pence. So what's that? 24, 240 and 3/8. 264. £2.64. So then the total amount payable then is going to be my £88 plus my £2.64. So total could be 88 plus £2.64, which is £90.64. Density equals mass over volume, and we're told that the mass of solid A is 6 times the mass of solid B, and the volume of solid A is 3 times the volume of solid B. So let's say that for solid B, let's say it has a mass of M and a volume of V. Then solid A then is going to be 6 times the mass of solid B, so that's going to have a mass of 6M, and it's going to have a volume 3 times that of volume B, so it's going to have a volume of 3V. So what is the density of B? So density for this one is going to be big M over V. And the density of our solid A is going to be a 6M over 3V. So simplifying that down, that's 2 lots of M over V. In other words, our solid A is going to have a density which is twice as big as solid B. So I'm going to say it is 2 times the density of solid B. Okay, in part B, we're given that average speed is equal to distance divided by time. If the distance is halved and the time is doubled, what happens to the average speed? Well, let's do the same trick as before. If we start off with a distance d and a time of t, then what happens then if we halve the distance? So now I've not got d, I've got a half of d, and I double the time, so half d over 2t. Okay, so basically I've got d over 2 divided by 2t. That's going to be equal to d over 4t. In other words, our average speed is going to be a quarter of what it was before, which is the same as dividing by 4. It's that one there. Question 23. A regular polygon has an exterior angle of 20 degrees. Work out the number of sides of the polygon. Okay. Now, a useful fact that you'll want to remember for your exam is that the sum of the exterior angles of any polygon is 360 degrees. So if you've got a regular one and you divide it by the number of sides, if you take 360 and you divide it by the number of sides, you'll get each exterior angle. So you can use that as a formula that an exterior angle of a regular polygon is equal to 360 divided by n, the number of sides. Now here we know the exterior angle and we want the number of sides, so we can just cross multiply these. So switching these two around, we're going to get n is equal to 360 divided by the exterior angle, which is 20. So cancelling those out, 36 divided by 2 is 18. So this polygon has got 18 sides. Question 24. The ratio half to 2/3 is the same as the ratio of x to 1. Circle the value of x. Okay, now this looks incredibly complicated to start off with. Let's see if we can figure it out. So the ratio of a half to 2/3 is the same thing as the ratio of x to 1. So basically what we want to do is we want to find out what this value is in this ratio. So we can just kind of resize this ratio so that the number on the right is equal to 1. I'm going to do that by multiplying both sides by 3 to start with. So if I multiply both sides by 3, then I'm going to get 3 over 2 is equivalent to 2/3 times 3, which is 2, isn't it? Okay. And now all I need to do then is divide both sides by 2. So what's half of 3/2? So dividing that by 2 is 3/4. So then x is going to be the value 3/4. So we've been given a group frequency table showing the times it takes 10 people to complete a task. And we can see that it took one person between 0 and 20 minutes to complete a task. It took 6 people between 20 and 40 minutes. And it took 3 people between 40 and 60 minutes to complete the task. Now there's a series of questions underneath that we need to decide whether or not are true or false, depending on the information we've been given. So the mean could be less than 20 minutes. Now, is that possible given the data that we've got in the table? Now, with group frequency tables, you do lose a little bit of the accuracy because we don't know for sure what value that one person who completed the time in between 0 and 20 minutes took. I mean, it could have taken them 1 minute or it could have taken them 20 minutes. So, depending on where within those ranges these people actually lie, is it possible for these things to have happened? So, could the mean be less than 20 minutes? Now, let's take this one person here who got a time between 0 and 20. The time needs to be strictly greater than 0, but we can use 0 as a boundary on this calculation nonetheless. So I'm going to assume that this one person took a time of 0 or as close to a 0 as it could get. So it's actually slightly bigger than 0. And the same, we'll take the lower bound of the other two. So let's assume these 6 people took just over 20 minutes and these 3 people took just over 40 minutes. Then multiplying those through, 1 times 0 is 0, 6 times 20 is 120, and 3 times 40 is 120. Gives you a total of 240 minutes. And if you divide that by 10, then that's going to give you a mean of 24. So the mean cannot be less than 20 minutes then, because if I take the smallest possible bounds, I only get a calculation of 24, so that's got to be false. The mean could be more than 40 minutes. Okay, let's do the same thing. At this time, let's assume then that it's the upper bound of those categories. So I'm going to have a time of 20, 40, and 60 for those 3 groups. So 1 times 20 is 20. 6 times 40 is 240, and 3 times 60 is 180. Now adding those up, 2180 is 200, and 240 is 440. Divide that by 10 is going to give you a mean of 44. So yes, it could be more than 40 minutes. That is true. The mean could be less than 40 minutes. Yeah, of course it could. We've said that we've shown that the mean has to lie somewhere between 240 and 24 and 44 now, haven't we? So it could easily be less than 40 minutes. Now, can the range be more than 40 minutes? Now, the range is the difference between the highest possible value and the lowest. So let's take the lowest possible value for time in the first category and the highest possible time there. That would give us a range of around about 60. So could the range be more than 40? Easily, yes it could. Could the range be less than 40 minutes? Okay, so let's assume that first person is at the upper bound then rather than the lower bound. So here at 20, And let's assume that all those three people are at the lower bound there of 40. Then the range of those would be 40 subtract 20, which would be 20. So could the range be less than 40 minutes? Yes, it could. And could the range be more than 60 minutes? Well, we said the range could be 60, but it can't be more than 60. That is definitely the upper boundary, so that is going to be false. Right, 36 is a product of its prime factors. Give your answer in index form. Now, I like to do these as a factor tree, so starting off with 36 as my top number, I need to find a pair of numbers that multiply together to give me 36. 3 and 12 spring to mind, so 3 goes there, 12 goes there. 3 times 12 is 36. Now 3 is prime, so we can stop on 3, but 12 is not prime. I can think of two other numbers that multiply together to give me 12. Let's choose 4 and 3. Again, 3 is prime, so that's a stopping number, but 4 isn't. I can break that down into 2 and 2, which are both primes. So looking at all of our terminating branches, multiplying those together will give us our original number. So 2 times 2 times 3 times 3 is going to be equal to 36. Always worth double checking these. 2 times 2 is 4, times 3 is 12, times 3 is 36. Now it does actually ask us to do it in an index form here, so we just need to write that in powers rather than as a sequence of multiplication. So 2 times 2 is 2 squared, and 3 times 3 is 3 squared. So our answer is 2 squared times 3 squared. Question 27. Circle the value of cos 90. Now you need to know all your sines, cosines and tangents for 0, 30, 60 and 90. I'll pop the table up on the screen now for you to have a look at. These are the values that you need to know. And then you can see from the table that the cos of 90 is 0. So that's my answer here. Now, in order to answer these sorts of questions, the only way of really doing it is memorizing this table. There are ways and means of doing it. You'll notice that the sines, for instance, are the same as the cosines written backwards. So actually, it's not quite as daunting as it first looks. And there are patterns through the numbers to help you kind of remember it. But it is a remembering task. It's one of those ones you'll have to make a flashcard for and look at regularly and test yourself on and see if you can memorize them all for the exam. It'd be a good idea just to double look at that card before you go in on the day, especially on the non-calculated paper, which is where they tend to test this. Okay, so anyway, cos 90 is 0. That's it. Solve the simultaneous equations 2x plus y is equal to 18 and x minus y is equal to 6. Now you should have a few methods up your sleeve for solving simultaneous equations, either by elimination or substitution or graphically. Here, this particular pair of equations lends themselves really well to elimination. You can see I've got a plus y and a minus y, so I can eliminate y very easily by adding these two equations together. So what is 2x plus x? It's 3x. What is y plus negative y? They're going to cancel each other out. And what is 18 plus 6? It's 24. So I've got 3x is equal to 24. That means that x must be equal to 24 divided by 3, which is 8. X is 8. Okay, so then I can just substitute that back into one of my original equations. Let's take the first one. So 2 lots of 8 plus y is equal to 18. So 16 plus y is 18. That gives me y is equal to 2. Then doesn't 18 take away 6? So my two answers then are x is 8 and y is 2. Now it's always worth just double checking these. We used the first equation, 2x plus y is equal to 18, for our working out of y. So let's just double check both solutions in the second equation. So check. I've got x minus y equals 6. So if x is equal to 8 and y is equal to 2, does that equal 6? Yes, it does. So that's just a quick check that you should do in the exam to make sure that you've got the right answer. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.